Welcome to The Explainer. Today, we're going to decode the story that's hidden in the DNA of over 1 billion people. And let me tell you, it's an incredible tale of ancient migrations, tangled ancestry, and a history that's still being written right now. Okay, so just to give you an idea of the scale we're talking about, get this. India is home to over 4,600 distinct ethnic groups. That makes it one of the most genetically diverse places on the entire planet. Seriously.
So right away, that brings up a massive question. With all of that diversity, is there even such a thing as a single Indian DNA? Well, the answer, as you're about to see, is kind of no and also kind of yes. All right, let's dive into this.
So here's how we're going to tackle this. First, we'll look at the 2 foundational pillars of Indian ancestry. Then, we'll see how they spread across the map. We're also going to get into a pretty famous historical debate. And finally, we'll explore why all this ancient history matters more than ever today. You know, the answer to our big question actually starts with a pretty simple idea. It turns out that nearly all of the genetic diversity across India can be understood as a mixture of just 2 ancient foundational populations. Scientists have given them names, ANI and ASI.
All right, first up, you've got the Ancestral South Indians, or ASI. Think of these as the descendants of the subcontinent's very first modern human inhabitants. We're talking indigenous hunter-gatherers with incredibly deep roots. Some of their maternal genetic lines have been in the region completely unbroken for an astonishing 65,000 years.
And then, on the other side, you have the Ancestral North Indians, or ANI. This group is genetically linked to people from West Eurasia. This includes groups like the early farmers from the Iranian plateau, and, much later, pastoralists who migrated in from the Central Asian steppe. Okay, so here's the key takeaway. You can think of ASI as the indigenous genetic bedrock of India. And ANI? That represents later waves of migration that brought new people and new genes into the subcontinent. The entire story of Indian DNA is really the story of how these 2 ancient groups met and mixed and created the populations we see today.
So, we have these 2 huge ancient populations. The big question is, how exactly did they mix? Well, as we're about to see, their meeting created this fascinating and surprisingly predictable genetic map across the whole of India.
See, the thing is, this mixing didn't happen evenly all over the place. Nope. Instead, it created this really cool, smooth gradient. Generally speaking, the amount of ANI ancestry is highest in the north, and it steadily drops as you move south. And of course, the amount of ASI ancestry does the exact opposite.
Let me give you a few examples to make this super clear. Up in the northwest, you've got Punjabi populations, and they show a really high percentage of ANI ancestry. Then way down south, you have Tamilians, who have a very high proportion of that ancient ASI ancestry. And in the west, groups like Gujaratis are somewhere in the middle, with a more balanced mix.
And wow, this chart just lays it all out, doesn't it? You can literally see that gradient in action as you move from Punjabis in the north to Gujaratis down to Tamilians in the south. You see the proportions just flip. It's such a powerful way to see this foundational principle of Indian genetics.
Okay, so now that we've got this whole ANI, ASI framework down, we can use it to look at one of the most famous and yet definitely one of the most controversial ideas in all of Indian history, the so-called Aryan Invasion.
For like 100 years, the story you'd hear was all about these horse-riding Aryans from Central Asia who supposedly invaded India, conquered the place, and destroyed its great civilization. But modern genetics and archaeology, well, they tell a very different and much more complex story.
And this timeline, it just perfectly shows you the biggest hole in that old invasion theory. The evidence shows that the Great Indus Valley Civilization was already in decline for centuries, probably because of climate change, before the people carrying steppe ancestry even began to show up. They couldn't have caused its collapse. So what we have now is a totally different picture. Science has pretty much replaced the invasion theory with what's called the steppe migration hypothesis. This wasn't one big, violent event. It was a much slower, more gradual process of smaller groups moving into the subcontinent over hundreds of years, mixing and integrating with the local people they met.
It was a cultural synthesis, not a replacement.
So you might be thinking, why does any of this matter? This all happened thousands of years ago. Well, the truth is, this ancient genetic story and the social history that came with it has some very real, very tangible consequences for over 1 billion people living in India today.
I mean, this stuff directly influences everything, from your risk for certain diseases, to social structures, right down to your own personal identity, and even the future of medicine itself.
Let's just take health, for example. It turns out some Indian populations have what's called a thrifty gene. It was an evolutionary trick that was super useful for surviving famines. But in the modern world, that same gene actually contributes to a higher genetic risk for type 2 diabetes, with the rate in some cities hitting around 30%.
And then there's this other huge factor. For about 2,000 years, the practice of endogamy, that's mirroring strictly within your own community or caste, has had this profound genetic impact. Over time, it's basically created thousands of little micro-populations, which can make rare genetic variations more common and increase the risk for certain disorders inside those groups.
Okay, and here's something that connects this story to an even deeper human past. Just like all modern humans whose ancestors came out of Africa, people in India carry, on average, about 1 to 2% of their DNA from our ancient cousins, the Neanderthals and the Denisovans. But here's the really wild part. Geneticists have found that about half of the Denisovan DNA found in Indian genomes, it's unique. You don't find it anywhere else on Earth. This is a huge clue that there was a very distinct, very ancient interaction between modern humans and Denisovans right there in South Asia.
So what does this all mean? It shows us that DNA isn't just some dusty record of the past. It's a living history. It connects everyone in this complex, interwoven, and incredibly diverse story. It proves there's no single simple Indian DNA. What you find instead is this beautiful, intricate mosaic, pieced together over tens of thousands of years. It's a map that reminds us that our identity is always deeper and we're all more connected than we could ever imagine.